Hi everyone, I'm Ms. Fazzone, and today we're going to be talking about factoring when a does not equal 1. So in past videos, I've talked about factoring using GCF, factoring using our product sum chart, factoring using the difference of two squares or dots, factoring completely, and factoring using slide. This is another day of slide, but I'm also going to include some review of the other types of factoring. So let's start with factoring these two problems. So when we look at number 1, pause the video, see what you think about it. When I look at this, certain things should pop out at you. The first is I notice there are x's everywhere. So in my head I know it has to be a GCF. So I know I have a GCF of x to the 5th. I take my smaller exponent. And then this was a tough one. I actually had to look at this before I taught it to you. I made this problem up a long time ago. What goes into both of those numbers? It's actually a 4. Sometimes you have to play around with the numbers. That's why we use a pencil in math a lot. So if we divide, we get 9x squared minus 40, see there's 3 left over, 49. Parentheses, GCF on the outside. Now if you notice, look at what's left. We're not done factoring. This is actually a factor completely. I can factor this inside. Which method is that? It's not GCF, I already did GCF. What else do we do with binomials? These are perfect squares with a subtraction. So I have a difference of two perfect squares, or dots. What times itself is 9x squared? 3x and 3x. What times itself is 49? 7 and 7. Remember, we need those opposite signs that make that middle term cancel out. And 4x to the 5th, the GCF. Alright, so that's a factor completely, GCF and dots. This next one, it's a little tricky. This is a straightforward product sum. There's nothing in front of x squared. I'm looking for two numbers whose product is negative 153 and sum is negative 6. Now I love giving problems like this that are a little harder for my higher level students so that you can't necessarily do it in your head. You need a method. The method is making this chart. Alright, so 2 doesn't go in, 3 times 51. Ooh, it's going to be 17 because 17 goes into 51. So 17, 3, 17 and 9. Nope, that doesn't work. It gives you 8. Ooh, this one might not be factorable. I think I messed it up. Unless I did it wrong. Yeah, I think this was supposed to be an 8. So this was actually not factorable. Or some teachers have you put prime. I think I meant for that to be an 8 for this to work. So, but the chart showed me that that was what's going to happen. Alright, let's do some sliding problems now. So in the last video I made, I showed you how to do these. We can't just look for numbers that multiply to 10 and add to 19 like in regular product sums. This 7 just changes the rules. So what we're going to do is we're going to slide that 7 to the back and say my product is 70. My product is 70 and my sum is 19. So let's find two numbers who multiply to 70 and add to 19. 2 and 35, 3 doesn't work, 4 doesn't work, 5 and 14, yeah, 5 and 14. So then when I make my parentheses, I don't know where that 7 goes. Because I don't know where it goes, I'm going to put it in both spots for now. And then I'm going to put in my plus 5 and my plus 14. And then I'm going to look, where do I see an extra term? Where do I have a GCF? There shouldn't be a GCF because this doesn't have a GCF. 7 and 5, those are prime. But here I can take out that 7. And we're left with x plus 2. And that's the answer. Alright, let's try the next one. I want you to pause the video and try this one on your own. So we're going to slide the 5 to the back. My product is negative 60. My sum is negative 28. Hopefully you're pretty good at these and this one popped in your head as 2 and 30. Who's going to be negative? 28 is negative, so my bigger number. So again, I don't know where my 5 is going. So I'm going to put it everywhere. Plus 2, minus 30. Look for your GCF, we're good here. But over here I can divide by 5. And we're done. Alright. This one's going to be a little harder, these two. So again, pause the video and see if you can figure them out. They're a little different. Process is still the same, but what we end up dividing by is a little different. So I'm going to slide to the back. My product is negative 20. My sum is 8. It's 2 and 10. My 2 is negative to give me a positive 8. So again, I don't know where the 20 goes, so I'm going to put it everywhere. 20x minus 2, 20x plus 10. Now notice I can't divide by 20 in either one of these, but I can divide here by 2, and I can divide here by 10. And 2 times 10 is 20. So I'm kind of taking some out of here and some out of here. So when I divide, I get 10x minus 1 and 2x plus 1. So these are the ones that are like a slightly harder. Okay, let's try number 6. Pause the video and try that one if you haven't. Alright, so 6 times 14 is negative 84. My sum is negative 17. Let's see, 2 and 42. 3 and 28. 4 and 21, that's it. 4 and 21 gives me 17. I need it to be a negative 17. So it's my 4 and 21. So we have 6x plus 4 and 6x minus 21. Remember I put 6 in both, and now we have to get rid of a 6 somehow. I can't get rid of an entire 6, but a partial 6. I can divide by 2. And we're left with 3x plus 2. Over here I can get rid of a 3, and I'm left with 2x minus 7. And these are nice, you can kind of check them quickly. 3 times 2 is 6, 2 times negative 7 is negative 14. So I'm pretty confident I got it right. Alright, this is the last one of the slide. Alright, these numbers are pretty big, so take your time. Pause the video and try it on your own. So 18 times 20 is 360. Yikes, negative 360. My sum is negative 9. Definitely not 2 and 180. 3 and 120. Let's see. How about 20? Well, it's not 20 and 18. Let's see. See, jumping around is never good. I shouldn't jump around, but 6 and 60. 6 and 60 doesn't work. 8 and 45. Nope. 9. 6, 12, and 30. Ooh, I think we're getting close. I bet it's 15. Let's see, 15 times twice 24. That's it. 15 and negative 24 gives you negative 29. So that's my thought process going through these. This is tricky. If you have a calculator, you know you're the texting generation, you can probably divide real quick. 360 divided by 10, 360 divided by 11, 360 divided by 12 to eventually get there. Alright, so then we do our 18 plus 15, 18x plus 15, and 18x minus 24, divide by our GCF, here we get a 3, so 6x plus 5, and here we get a 6, 3x minus 4. And this is pretty as hard as it gets. I mean, I guess it could get harder if you had like crazy GCFs in here, but this one's as tricky as I think I would ever get as a teacher. Alright, so this last slide, we're not going to actually factor anything, but I want you to look at the problems and decide whether the following are how they're factored. Which method would you use? So pause the video and just write down which method, or even just think about which method for each. So for A, which one is it? The key idea here is there's nothing in front of x squared. A is 1. So because A is 1, it's a product sum. Letter B. What do you notice here? It's subtraction, and they're not perfect squares. I see x's everywhere. That's a GCF. Letter C. It's a trinomial. Can I do a GCF? I can't. There's nothing. Since there's a number in front of x squared, that's my slide. Letter D. It's a binomial. Check for GCF. Nothing goes into either, but I have perfect squares and subtraction. That's my dots. Letter E. Trinomial, a number in front of x squared, but can I divide by it? I can. That's a GCF, and it's most likely a product sum when I'm done. So that's actually a complete thing. This last one, notice there's not even a square in there. So this is a super basic GCF problem. I can divide by 5. So being able to recognize which factoring method is super important. I'm not just going to give my students like 50 GCF problems and then 50 multiply or product sum problems. You need to be able to recognize which type is which. Okay? Hope this was helpful. Have a great day.